Well, hi guys and girls, Emma again. Welcome back to the spare room. There's a lot of little projects on this dividing head, and a lot of it's been covered in my Wednesday Night Live. But today I wanted to sort of go through making a thread protector for the spindle here. We've got this sorted so we can put collets in here. This is the right angle on the end and the right diameter. We've put a key there with a flat. I don't think you can see that. You might be able to. Probably not. It's only tiny. A key with a flat on it, or alongside to go in the slot on the collet. And we still need to put a mark on here so that we can easily get these in the right way, lined up with the collet, with the key. So that's how that works. Put that together. There's still quite a few little jobs to do. One of them is to put a keyway in this bronze gear, and some dividing plates in the spring detent, things like that. But we've sorted this out. We've got a draw tube that works, which is a cut down launch one. Next thing is a thread protector. So I thought this video is probably not for everyone, but I wanted to go through some of the procedure for sorting these out in Onshape so that we're drawing it up, and some of the trials and tribulations of actually printing one that works, and then having a look at the finished one. So let's go across to the computer and have a look at the model and what I come up with, and then have a look at making up a P-code file and printing it, and what we go through to get one that actually works. So I started with a circle. It's 25mm, the same as the outside diameter of the thread, and I made a feature here, just something to get hold of with my fingers, and arrayed that round the circle. So what we've got is a double circle there, and we can extrude that. If we make that 25mm long, we've got the basic shape of what we're going to start with. Next job is to put a thread in it. It's 25 by 2.5. In a perfect world, that should screw on nicely on the spindle, but it doesn't quite, I don't think, and we'll look at that in a minute. I wanted to cut the back out, so it's just so that it screws all the way up the thread. So about 4 or 5mm out the back. If we just draw a circle and then subtract that from the thread, that should give us enough of a land there to go over the plain part on the back of the thread, especially on the lathe. I wanted to put a chamfer on the top here, and you can't really do that with this shape the way I've done this, because you've got a double diameter there. So what I've done is just drawn 2 circles, made a rough shape, a second piece there, and put a chamfer on the inside corner to match what I want to do. And if we have a look at that, we can see the overlaps there. And that'll, if we take this part here from this part, then that'll disappear, that sharp corner. So just do a subtraction there, and we end up with a nice chamfer. Still think it needs probably a rim on the outside, so I've sketched that in. Look there at that sketch. We just extrude that up a couple of millimetres too, and that'll give us our finished item. If we right click down there, we can go export and export it as, name it and export it as STL and then metric to our download folder. Click OK. And then we can open it nicely in our slicer software. This is a slicer that comes with my printer, and I quite like it because I got used to it before I tried anything else. It's fairly basic, but it does seem to work, and some fancy features it doesn't do, but it's not too shabby, and it's within my learning curve, so it's what I tend to use. I'm going to print it with a raft because I'm only printing on a black plastic sheet. And I don't know how flat it is. It seems to have put in some automatic support in the bottom there. I'm not sure why. But we can look at the print as it builds up there. This is going to take 1 hour and 13 minutes. So if we save that to a SD card and put them in the printer and see what we end up with. I forgot to add that I've scaled that to about 0.35 of a millimetre bigger on the X and the Y direction, not in the Z direction, because that would change the pitch of the screw thread. So just in the other two directions, and hopefully, with any luck, we'll have something that will screw on. This print took a bit over an hour. I've sped this right up. Poor little printer's working pretty hard. There's many upgrades that could happen to this, but it's, at this point, for this sort of thing, it's serviceable and it makes quite nice prints, but you can see that the print bed there has got a nasty bow in it, and I think the next job will be to either to fit a mirror or a proper heated print bed. Check out the tool making competition. It's on again. It's very current at the moment. There was a pop-up from Chirpy in the video to watch. I haven't watched it yet, but I'm going to go and do that directly while this is processing. So in the end, I ran a tap through there. It didn't need a lot out of it, and I was able to push it through with my hand, but it sort of kept most of my skin doing so. And we've got a reasonable quality printed part. It's got the land in there, and our notches around the outside, and our chamfer on the top, and then a build around the bottom there just to make it look good. And that screws on over. So there's more than one way to skin a cat, and that's how I've made this. I'm quite pleased with it. It also fits the lathe quite nicely, so anyone who's been wondering when I'm going to get one for the lathe spindle, I've finally done that job. But that gives us a fairly nice, neat and quite smart thread protector for this particular build. So on to the next parts. Thanks for watching, and thanks for subscribing, and don't forget to like and all that sort of stuff. Be kind to each other, and more soon.